Okay, today we are going to demonstrate about this FX40 Park AFM system. So it's very user friendly and based on the AI system, artificial intelligence. So here this is the place, like we are using the head and downside in the left is called the sample, and everything is automatic, like alignment, pick up the cantilevers and selecting the sample. So let us see how it is working. For example, these are the software here. So if you can look that in the first node, this is called the optical view. So for example, like for the probe, if you can click the probe, so you can see that these are the probes, is option is coming here, but in the left side we are not able to see anything, means the probe. So what we have to do, that first of all, like we have to just click on the load. So once you can click the load, you can see that this is the all QR code based the cantilever. So next step, like you have to click on the detection part. So once you can click on the detection, detect means they are able to identify in the green color on the cantilever. So now I just pick from here and it is already cantilever has been picked. So I want to demonstrate here like how we can place the cantilever back to here. So for placing back to here, like what we have to do, that simply you have to click it here. This is the numbers, like you can see that number 1, number 2 and number 1, number 2. Similarly we can identify from here, and I'll just select it here, then I can click it. This is called like park into. So once you can click that, you can see that they will move from here, and similarly they are going there and they will place the cantilever in the same option there. So you can see that similarly they are going to the same place and they will place it here. So now they have placed that already there. So same, if you can come back to here, we are not able to see anything in this optical view. So similarly, like again I want to pick the same cantilever back for doing the one standard sample here. So what we have to do, that the same way I can click on the probe. For example, I can click the probe, then you have to click on the load. Once you can click on the load, and we have to wait once the sound is finished, then second option we have to just select on the detect options. So once you can click that, they will detect the all cantilever there. But here you can notice that like it still is showing that the missing, but in the reality we have already placed it back to there. So what we have to do, that like you can just expand this one and minimize it, and again click it on the probe, and then we can just click on the load one more time. Okay, and then once you can click the load, then if you can click on the detect option, so you can see that like the all probe is already placed back to there. So same way, like I want to place the same cantilever, this is called the NCHR option 2. I can just click here, and then the option is called like picked up. So if you can click, this is called the pick at. So they will go there, they will pick the cantilever. The similarly, if you can look at here, they're just going down, they will just pick the cantilever. You can see that is just going down. So already placed by the AFM system, and everything is automatic, like we don't have to do anything like alignment in X, Y, Z. So everything they will do by self. It's very unique device, like I don't think any other manufacturer have this facility to make the alignment automatically. Similarly, you can see that the cantilever has been picked by the AFM system. Next, about like what we can do from here, I can just expand this option, and then you can see that it is automatically has been aligned by the system. Suppose in case if you feeling that is not aligned well, so simply you have to just click at the aligned option. Next, about like we have just done the alignment of the AFM probe. The second option is called how we can go to the sample. So doing the sample, we know that like AFM either can be used like the contact mode, non-contact mode. So here I can close this one, the optical view. Either you can just align, either take up or down, and we can just see that the image inside that. We can close this part. Once you can close, simply we can click on the sample option. because our objective to just look for the sample. So here we can see that in the left side this is our sample. So same way we can place your sample in anywhere. For example, like your sample is placed in the left side, you can place in the left, here right, you can place that. Now our sample, it is in the exactly in the left side, so I can take from the center and we can place it here. Then I will click that go to. Once you can click on the go to, same way we can see that like what is happening here, like the head is going up and they will move to the sample location. For example, you can see that this is just going to the sample location there. So the second step is that like we have moved our sample there, and then we have to go to the here, like this is called the setup. And the next step, the setup, we have to select our mode. For example, I want to do the non-contact mode, I will do the non-contact mode. So we know that like in the non-contact mode, this is called the tuning. So automatically the system is doing the tuning here. And then once the tuning is finished, tuning means like they are looking for the resonance frequency, where the frequency and high amplitude. So the system is recommending for 12.2 nanometers of the approaching amplitude. So I just close this one. I'll come to the scan area. I have selected 18 micron by 80 micron. You can select as per your requirement. The second options, like I just clean the previous scanning. The second option is called like scan area jet servo. So we have just placed the 12.190 as a set point. Next step, like we have to approach to our sample. I expand this one, and you can see that there is a two kind of mode here. Mode means like we have to move down. For example, like focus stage, this is called like the G scan. So we are very far away. If you can look that, we are very far away from the sample. So what we have to do that, like from here, first of all we have to approach down by help of this software. For example, I can come downside here and I'll use the software. Like I just trying to go downside, and in the same time we also notice that like what is the distance, because sometimes it's happening that like we are keep going down and we are not looking there, and we are, there is a chance to crush our cantilever. So what we have to do that, for my experience I know that like once we can reach almost the 20,000 this value, we are close to the sample. So just I'm going down. Okay, so just is for 24,023. Similarly, I just trying to go slowly down. It's almost 20,600. I just try to go down. Then we can look in this side also, like what is the gap between sample and cantilever. Is looking very close. It's looking very close. This is the cantilever, so we can adjust the focus and we can see that like we are able to see our sample in the camera or not. So I can come back to here. I'll use the another knob here. For example, what I can do, just I'll try to take it down. For example, can I see that something? No, I cannot see that, but you notice that in the left side the some signal is coming and we are feeling the some a scanner movement. We can close this one. We can close this line scan, then it will be stable. I can expand it again here, and then I can just try to go down. If I can see something, I can't see, so I can just go little down. It's showing that the PSPD is out of alignment, so I can just take it this one up, little up, little up, little up. Okay, I'll try to go down. Okay, it's almost 20,000. I can just try to look that if I can see something. I think I'm able to see downside. See, this is our sample. We can see from here. But one thing, if you notice that this is not our exactly the sample, so what we have to do, that I can just click that, I can just off the beam here, then we can just move that. Where is our sample? If I can see something, no, okay, the green part is look like our sample, so I can just come to here. Okay, this is arrow is indicating that if you can go to this area, we are able to see our sample. So these are the samples area. I can quickly come to here, then I can use the guideline. Guide means they are going to approach in this location, so I just make it much clear here. I can take it up. If I can see something, I think I am able to see nicely now. So this is our area of interest where I want to scan that. So similarly I can just use this line here, maybe slowly more, it's too fast. I can just go to here, bit here, either here. You can use this line, just you can minimize it, maybe the light is here. So this is look fine, this area look fine for me. I will do one thing, I can right click here and I'll go to the cantilever first. The cantilever is here. I'll turn on the beam, then I can go for, this is called the auto alignment. Simply I'll click the auto alignment, and here like the system will automatically, you can see that they are doing the alignment part. So it's completely new based on the AI system, and they know that like mirror movement, laser points, and they're just doing the vertical and lateral resolutions almost zero, and they're trying to make the alignment here. Next about, we can just close it here, and then we know that like in the non-contact mode we have to do the sweeping. So I just am trying to do the quickly the sweep between the amplitude and frequency here, then we can going to approach next. So once they are finished, we are going to approach. Okay, so quickly I can do, I will close that. The system is recommending to us the 12.1 nanometer as a set point. I can come to the scan area, this Z, and these are the set points. So I can just click on the approach here, simply approach, and once you can approach that, you can see that how quickly they are reaching to our sample. So once they will approach, we are going to get some signal, like they will appear the message that we have reached to the sample, and one more indication that this Z scanner is going to be 0. Now we can see that the some value of this Z scanner, it is on the negative value. So we are just waiting to make it somewhere in the 0 point something. It means that we have reached to our sample. Okay, so once we are here, we can see that like Z is almost 0 point something. I can start the line scan, and but our scanning is very fast, so I will just reduce that. For the scanning rate I can go 0.5. okay, and then I can just select it here. This is called the auto scaling. I will select that, and then I can select the auto leveling. Okay, so what we can do from here, I can just reduce this value, like for example I can go 11.50, the set point. The second thing we can do from here, that we can just select the some gain value. I can select 1.50. okay, so I can just increase this value. I can go 2.5, 2.5. okay, I can just reduce one more time, like 11. I can click it, then I can go to the 10.50. okay, and here I can just increase the set point. We can increase the set point again, like we can reduce, like we can go to the 2. I can increase this value. 2.5 here also, 2.5 here also. We can again increase little bit, like we can put this 2 and put this 2, okay, and this bit is like I can put 3. Let us see if any improvement. Quickly I want to start the scanning. Okay, so you can see that this profile forward and backward is almost same, and the error signal is 1 nanometer. So for making this one, like if we can reduce this speed, if we can go to the 0.4, okay, so it's looking like some profile. So we can just start this scanning here. I can little bit, if you want we can try a little bit higher and see that if there's any changes, good changes. 3.5, okay, it's look good. So we can start the scanning here. So once we can start the scanning, we can see that okay, I can see like you can see the FFT here labeling. I can remove that, okay, because see, like I just want to scan very quickly, that I cannot see this is the best image. They are adding some noise. We can play with more some option like jet gain and the set point, and we can see that where we are getting the best image. But we are able to get some pattern here. You can see that if we are getting some pattern here. So that is the fine, like how we are using this auto AI based the FM system, and it is very user friendly to use. That is, everything is automated. Alignment is the big challenge for the any FM manufacturer. It's big challenge, like we have to align X, Y, then mirror, and it will take a lot of time. So now in this image you can see that they are adding some noise. Basically we are doing on the high gain. So other option is that, like I can just stop it here quickly. I can just stop it here. I will just take some height. For example, I just cancel this one. I can take 15 micron. I will stop this line scan also. 50 micron, 50 micron, 50 micron. So here, like if you can make this expand this window, so you can see that the vertical they have the error here. So for doing this one, like we can do one more thing, like we can just close this one. I can go 50 micron, 50 micron, like 100 micron up. I'll expand this one, and then quickly I can just go one more time the auto alignment. Why I'm doing this one? Because once the vertical and lateral is 0, so there is a chance that like the system will get the much offset to start the scanning on the different level of amplitude. So what we can do from here, like you can see that the vertical and lateral is 0 0 right now. I'll just close it here, and I'll try to quickly approach, and you can see that like what is happening. I can just go to the approach. You can see that now it's trying to approach it here, and then we can see that like if it is better image compared to previous one, then we can continue again for doing the scanning in the same area. Next about, like I'll demonstrate that how we can close that. So we are just doing the one sample here, and you can see that like I did not close the door also. So AFM can play the different parameter about for the good image, like if your door should be closed, and we have to door should like there is no external vibrations condition here. So what we can do again from here, like if we can go to the line scan. In the same line, I can just click it here. I can remove the labeling. You can see that some pattern is coming here. Okay, so in that case, like I can just reduce this value, for example 3. The always high gain is not a good idea, so you can put it 3 here. I can just go to the auto scaling. Okay, so the some pattern is coming, but it's not I can see this, I cannot say that this is the good image, but we have to play with the several other parameters to get a good image quickly. They're adding the noise. I can just, you can reduce the set point. Yeah, this is looking a bit nice. Okay, this will look bit nice. I can start the scanning here. Okay, so you can see that there are signal is almost some of the angstrom, so this is fine, not bad. Okay, so here you can just select that like phase, you can select the phase, you can select the amplitude, we can see the different kind of pattern. This is called the height, means the vertical resolution, so some image is coming. If you can click that, they will just show the present value. So you can click on the fittings. Fitting means they are just making the nice color. We can change the color also. So there's a lot of options. So now I have to close this one. So for closing is also very simple. What we have to do that, like from here we can, I will just stop this one. Like we can cancel this scanning from here, and once you can cancel it, like the second option, we can just stop this line scan, take this lift like 100 micron up, 200 micron up. So you can just click on the 200 micro up, 200 micro up. So now I have to remove the sample, so I can go to the sample part here, and simply if you can click the unload here, unload, if you can click the unload, so you can see that there what is happening. The head is going up, head is going up now, and this sample is moving there. Okay, so next about, I can go back to the probe here, I can go back, I can click to the probe here, and same manner what I'll do that in this case, like I can just click on the load. Okay, so you can see that this is the green, means they have the magnetic field. I'll click on the detect. If once you can click on the detect, you can see that the green line like is covered with the green line, means they are detecting the probe. So I'll simply click it here, then I can click the park into. So once you can click that, you can see that they will move to that location, and see, they are going to place the cantilever back to the same place of the probe. Once we have done that, like then simply we are going to remove the cassette. For removing the cassette, what we have to do that, we have to click, this is called unload from here. Once you can click the unload, so they will just separate out the cantilever, and we can fix it and we can remove it out. So you can see that how we are using this FX40 system. Thanks for watching.